just received chemistry paper of ICSE Board Class 10, and I have already solved section A question 1 as a video. The link will be somewhere on the right hand side for that. Then the second video I have posted is of question 2 and question 3. So 2 and 3 are the second video. Then I come to the next one, question number 4 and 5, that also I have uploaded. So you will see somewhere on the right hand side the links. And now we are coming to question number 6 and 7. Let us look at question number 6. Given below is a diagram showing the placement of 5 different oxides with respect to the given diagram, and answer the following questions. So you have some here. Let us just look at the questions so that I get fair idea about how to answer looking at this. Name the type of oxides represented in region X. Identify oxide which has been incorrectly placed in the above diagram. Here they say these are basic oxides, so these are metal oxides. And here they say they are acidic oxide. So S is a non-metal, but is copper a non-metal? So copper is a metal. This has been wrongly placed. And name the oxide in the above diagram which will form alkali when dissolved in water. So that will be an alkali metal. Which is the alkali metal from Na and Fe? It will be this. So what would be our answers? Our answers, the first one, the X, is going to be neither basic nor acidic. It will show dual character. So that is, it will act as a base as well as acid. So that is amphoteric oxide. For your B, incorrectly placed is CuO, since not a non-metallic oxide. Therefore, it is not acidic. It is a basic oxide. Should have been here. Name the oxide which will form alkali. That will be the alkali metal. That is Na2O. We come to the second subpart of question 6. Given below are organic compounds from A to F. There are 3 subparts only, A, B, C. Is there any more? No. Okay, just wanted to check that. So answer the following. Which are the compounds which form a single product with bromine? So bromine, if it is an alkane like CH4, it will not have a single product. It will have total 4 products, correct? CH3Br, CH2Br2 and CHBr3 and CBr4. Okay, so we want only single product, so it is not going to be just charging the laptop. Yeah, so it will be with a double bond, and even with triple bond it will give you 2 products, because triple bond becomes double bond becomes single bond. So here it will be double bond here, so the bromine reagent will attack this and it will become C single bond C with Br here added up and these 2 earlier H's. So it will be 1,2-dibromoethane. So single product will be for A, it will be C. Let us look at B. 2 compounds which have same molecular formula. Same molecular formula means they will have the same functional group. We have here oic acid, this is alcohol, this is alkene, so we have to look amongst D, E and F. D has 4 carbons, this has 2, so this is out. Then D and F, what are they? 1, 2, 3, 4 carbons. Can you see that? And number of hydrogens also are the same. So the same molecular formula will be D and F. Two compounds which will react together in presence of concentrated H2SO4 to form a fruity smell means they will form ester. So ester means it will be alcohol and acid. So can you see this is ethanoic acid, and this will be ethanol. So this is going to form the esterification reaction and it will give the ester. So we will write A and B. Have they asked us to write the reaction? No. So it is too simple. The paper is too simple. You can write how many marks have you got in this so far. Now look at this organic compound. Organic compound, the third subpart says contains carbon, oxygen and hydrogen only. The percentage of carbon and hydrogen are 47.4, 10.5 respectively for carbon and hydrogen. So oxygen is going to be this, and this you add, that will be 57.9 and will subtract from 100. So that will give us the percentage of oxygen. The relative molecular mass of X is 76. Find the empirical formula and the molecular formula of X. Now this by and large can confuse some of you because of the irritating calculations, but let us just look at it. Let us make the columns. This is your elements. Then we have the percentage composition. Then we'll have the atomic weights. Then we'll have the relative number of atoms, and the last will be the simple whole number ratio. So I'll just quickly write atomic weight, a relative number of atoms. Please write the full form here. Do not use any shortcuts. So we have carbon, then we have hydrogen, then we have oxygen. Carbon is 47.4%, atomic weight is 12. Hydrogen is 10.5% and atomic weight is 1. And oxygen will be 100 minus 57.9, which is equal to 42.1%. And here we are going to have the atomic weight as 16. Relative number of atoms will be 47.4 upon 12. 10.5 upon 1 and 42.1 upon 16. This one will give me 10.5. Yes. Now I have to show the working. So I will show the working here itself. 12 is dividing 47.4. So 12 4s 48. So it will be 12 3s 36. Remain 1 here and 12 ones. 12 3s. Sorry, made a mistake. Sorry, so it will be 11.11 and 4 here down. So it will go 12 9s 108, and that will give you 6 here, and then I have to take 0 and 3.95. So I have 3.95 here. In the last one, 16 is dividing 42.1. So 16 3 is 48. So it will be 16 2s 32, remain 10, take this 1. So decimal point and 16 6s 96 and remain 5 here. So it will be 2.61, but I think we could take it rounded off to 1 decimal place. Yeah, so this one will give the simple whole number ratio, 2.6 being the lowest. So we can have 3.95. I don't want to round this off, upon 2.6, and here it will be 10.5 divided by 2.6, and here 2.6 divided by 2.6. This is 1. Now the calculations of this are a little annoying, but let us see what can we do. If we round off to 4, 4 divided by 26, if I do, how much would I get? So this will be 40 upon 26, right? If I round off to 1 decimal place, it becomes 4 upon 26 and 2.6, so it will be 40. So it will become 20 upon 13. That would be a little better than dividing by 26. So 13 is dividing 20. 13 ones 13, remain 7 decimal point, and 13 5s is 65. So we can easily write over here 1.5 for the first part. Okay, for carbon. Now here again it's a little bit irritating. 2.6, that means 26 is dividing 105. So 26 into 4. How much is 26 into 4? 52 into 2. So that is 104 aata hai. So it is going to be 4 point and this will be 104. So you'll have 1 remaining. Take 0 decimal point and then again you'll have to take this and 4.0 something. So it is coming 4 times. Can you see this is 1.5 and 4 and 1? We can't have fraction. Simple whole number ratio means you have to multiply by 2 here, multiply by 2 here, and multiply by 2 here. So we get here 3. I don't have space. I think I'll write it here 3. This is 8 and this is 2. So your empirical formula is CO3 H8 and O2. So this is our first answer here. They're asking for empirical formula. So that is your answer 1. Now the empirical formula weight we'll have to find out. So empirical formula weight is 12 3s 36 plus 8 into 1, that is 8, and 16 2s 32. How much is that? 614, 16, 76. And your molecular weight RMM has already been given. Your RMM is 76. So your N is going to be equal to molecular formula weight or RMM divided by empirical formula weight, which means it will be 76 upon 76, which is 1. So the molecular formula is going to be equal to N into empirical formula, which is 1 into C3H8O2, which is C3H8O2, and that is our answer. This by and large really made your work for those 4 marks, right? quite a few of these calculations you have to do, but it's worth it because remaining paper is relatively easy. So question number 6, if you don't like the calculations, you could easily have kept it for option. But if you have attempted it, tell me out of these 10 in question 6, how much did you get? Write it in the comments, okay? Let us come to question number 7. Question number 7, Seema adds a few pieces of copper turnings to a concentrated acid P, and if she saw reddish brown gas, then acid P is going to be concanitric acid. Did you write concentrated or you wrote only nitric acid? Concentrated nitric acid. Because if it is dilute nitric acid or moderately concentrated nitric acid, it will not give NO2, it will give NO, that is nitric oxide. I hope you have underlined this concentrated. Okay, write the balanced equation that for the reaction that took place. So we have copper and 4HNO3 conc. Of course, you know how to remember these reactions. So copper nitrate will be CuNO3 twice plus 2H2O plus 2NO2. All right. So we have the tricks to remember these, and I hope your teachers have taught you that. The second one, answer the following questions with reference to concentration of bauxite ore. What is the process for concentration? Isn't it Bayer's process? So it is Bayer's process where we use sodium hydroxide. What are they saying? Give balanced equation for the conversion of aluminium hydroxide to pure alumina. Now in the third step, AlOH thrice, that is aluminium hydroxide, for 1100 degrees C, it will give Al2O3 plus it will give you H2O. So Al2 means I'll have to take this and I'll get 3H2O. Okay, so that is our reaction. Let us come to the third subpart. Third subpart is for 3 mark. Let us see what they are asking us. Draw dot and cross structure for the following. The ionic compound formed when Mg reacts with HCl. Mg reacts with HCl, which means MgCl2 will be formed. So they are saying draw the formation of MgCl2. So Mg is going to be 12. So 2H2, it will have 2 electrons in the valence shell. And chlorine is 2H7. So 1, 2, 3, 4, 5, 6, 7. So 1 electron will go to this chlorine, making it an anion. And 1 more chlorine will be required for accepting the second electron, and that will give us Mg. This was 282, has now become 28. It has become stable electronic configuration, but as a result it has got 2 plus charge, and plus it will have 2 chlorines, and these chlorines are anions. They were 287 before the exchange of electrons, and it becomes now 288, and that gives us MgCl2. So this is the first answer. Your B part says covalent compound formed between hydrogen and chlorine. So we have hydrogen, which is electronic configuration 1, all right, and we have chlorine, which is 287. Chlorine is 1, 2, 3, 4, 5, 6, 7, and this hydrogen electron and this chlorine electrons, they are shared, forming H with this kind of structure, correct? Because H has formed the duplet, Cl has formed the octet, and that will give you H single bond Cl, and that is our HCl, which is formed between H2 and Cl2, which is actually an explosive reaction. Glad that didn't ask you for some more questions based on this. It's just direct this formation of electron dot diagram, so it's fine. Let us come to C. The positive ion formed when ammonia gas is dissolved in water. Now, when it dissolves in water, your ammonia gas is ammonia. This is ammonia and this is its lone pair. It is dissolved in water, so it will have H1 plus and OH1 minus here. They have told water, so I have to mention this water. This electron pair will be donated to the hydrogen, so it will become nitrogen with a single bond here, with a single bond here, with a single bond here, and this is now given to this hydrogen. So this entire thing will have positive charge plus OH1 minus, and that will give us NH4 1 plus and OH1 minus. So we can write this as, because they say the ion, positive ion form. So I cannot write NH4OH. Let me just write it here as N single bond H, single bond H, single bond H, and coordinate covalent H, and this full thing will have plus, and that will give us in the next step NH4 1 plus plus OH1 minus, and this is the ammonium. They are asking for the positive radical, so it is ammonium ion, and this was ammonia. Now if you want this, you could have, let me just change the ink and show you. This could have been here this way and this way hydrogen, this way and this way hydrogen, and this way and this way hydrogen, and everywhere you could have planted this dot and cross for nitrogen and hydrogen, and then you could have shown the bond formation. Either way, you should be able to get marks. It was only for 1 mark. They cannot not give you that mark. So that is the end of question 7, third part. We come to the fourth subpart. Fourth subpart, acidulated water is electrolyzed using platinum electrodes. Acidulated water, why is it acidulated? What will you say? That pure water is almost a non-conductor of electricity. Correct? Now, when we add the acid, the dilute acid dissociates into H1 plus and SO4 2 minus. So there will be 2 H1 plus and SO4 2 minus. Correct? And this is going to help in dissociation of water. What you have to mention, that water is a polar covalent compound. So it dissociates water into H1 plus and OH1 minus, and therefore conduction of electricity is possible. I'm just writing the key phrases here so that you can formulate your own answer in your own words. Make sure that you are writing these: pure water, dilute acid, this, water, polar covalent, this will be dissociation, and then it will conduct electricity. Okay, so I'm just providing with the key words. Write the reaction taking place at cathode. For cathode, the cations are going to migrate. So cation is going to accept one electron and it will become H. But this is not the entire process. You need, in order to have hydrogen, you will have to have 4 electrons, because side by side, remember, at anode 4 OHs are losing 4 electrons. So those 4 electrons are accepted here, and that will give us 4H. That means it will give you 2H and 2H. That will give us 2H2. And that is how we have 2 volumes of hydrogen which is produced or formed at the cathode. C part. What is the observation at anode? At anode, you will have OH1 minus losing an electron, becoming OH, and you multiply the whole thing by 4, because OH by itself is unstable. So 4OH is going to give us 2H2O plus O2 up arrow. So observation, below this you will write that one volume of colorless, odorless oxygen gas is formed. Where? At the anode. And that becomes your answer C. And this is the thinking part for that. Okay, the actual answer is here, this one. So that finishes our question number 6 and 7. I want to stop this video here and go to question number 8 in the next video. Otherwise, each video becomes too long. Okay, I'll see you in the next video. Bye.